In the corridor properties, you can change many things, such as the code set style, the feature lines that will display for plotting, and so on. Let's go ahead and examine these. I'm going to zoom into my corridor, and let's first select it. Then, in the contextual sensitive ribbon, let's go ahead and choose corridor properties. First, the information tab allows you to change the name, and the style. Again, the style is not going to control the display of the links, points, and shapes. It simply controls what displays as far as regions, graphics, and so on. The parameters tab should look familiar. When we first created our corridor, this is where you added baselines, set frequencies, and set your targets. So what's great about the properties dialog box is the fact that you can change any of those settings that you initially had defined. For instance, let's say around curves, I want to make my modeling a little bit tighter to make it a little bit more of an accurate model. So I'll go to set all frequencies, and then I'll go to the curves section, and I'll just type in, let's say, 10. So every 10 feet, it'll model. We'll do the same thing for profile curves. Click OK, click Apply. It'll ask us to rebuild or mark the corridors out of date, and we'll go ahead and rebuild the corridor. And you'll start to see that in the background here, around curves, we get a little bit of a tighter modeling. Again, you can also change any of your targets depending on the region that you select. Note that in this case, I have two baselines that I've also entered here. One is for the existing alignment and existing conditions to tie into the proposed alignment and proposed assembly. The Codes tab is where you define the code set style that you want to apply to the corridor object. Let's say I want to change this to a more visualization type code set style. I'll go ahead and pick it from the code set style dropdown, click Apply, and notice how the links, points, and shapes have all disappeared because the code set style has turned them off. Again, this is the automation that needs to be created so that you can plot much easier and faster when you're ready to plot your drawings. The Feature Lines tab is where you define what feature lines should display for your corridor object. Here's where you can actually automate what linear graphics you actually want to display for plotting. Any of the feature lines within the corridor object use a feature line style defined in the Settings tab. I'll select all of these by simply picking the top one, holding the Shift key down and navigating to the bottom one, and then I'll click in the feature line style, and I'll set this to a feature line style that I created called _no_display, so it puts it at the top of the list. Notice there is not an option for none, so to turn them all off, I'll just simply select that feature line style that I created, click OK, then I'll hit Apply here, and you'll notice here that they all disappear. So now what I want to do is I want to actually turn on the ones that I want to see. So I can sort this if I want to, and let's say we actually do want to see the back of curves, so I'll go ahead and click on this one here. And depending on what your company standards are, you may not need to set too many of these feature line styles. Maybe you'll need to set ones for plot and no plot, or display and no display, or different types of display resolution. I'll go ahead and select the corridor curve line for this one. Click OK. I don't need the crown because I have this center line. I would like the daylight. I'll put them all in the same exact feature line style. Notice how I can select multiple. For edge of travel way, we'll go ahead and do this one as well. And for the sidewalks, we'll also do those as well. Click Apply, and notice how in the background, we're just getting the line work that we want. The Surfaces tab we will discuss in a future video, but this is how you can create proposed surfaces once your design is done. The Boundaries tab works in conjunction with the Surfaces tab to bound your surface so you don't get any erroneous triangles. Slope patterns are not widely used, but allow you to add a pattern to a certain slope between two feature lines if your plot sets require a slope pattern of some sort. I'll click OK, and there's our completed model. One of the other things that you can do is select your corridor object, and notice how these grips appear. So if I want to change where this region actually is starting from, I can actually go ahead and change that by simply moving this grip. The model will automatically rebuild itself. Note that some of the properties are already defined right here in the contextual ribbon, and you actually don't need to go to the full corridor properties dialog box. This concludes this video discussing corridor properties. Once your corridor is built, you can generate a surface from it. To do so, first you would select your corridor object. In the Corridor Contextual tab, you select the corridor surfaces. Note, you can also go to the corridor properties dialog box, which will open all the different tabs, but this one here opens just this specific tab for corridor surfaces. There are two ways to add surface information from your corridor. You can add links and feature lines. First, let's start with the links. So again, the links will be the actual links that generate transversely across the corridor object. The code that you want to actually use is also the top code to generate a top surface as well. We'll also generate a datum surface so that we can use that for cut and fill volume quantities. Let's go ahead and click on the new surface entry. And in here, you can actually give it the name. So I just clicked in there once, and we'll call this one bypass-1. As with every surface, you need to select a surface style. So I'll just go ahead and pick the contours 2-foot, 10-foot design and click OK. The overhang correction is actually very important. This way, what you want to do is set this one to top links, because in the past, what would happen is sometimes the points about which that it would connect within the subassembly would actually go from the top of curb down to the bottom of curb, and you would get improper triangulation. This one will actually allow you to make sure it does all the top links, and if you do a datum surface, you would pick all the bottom links. Once you have your surface entry, then you can start adding the different data types within the actual corridor model. So that's all that this dialog box is doing. Is it saying, I want links, and then I want to add a specific code. And these are all the link codes within that surface. So since I want to create a top surface for all of my corridor, I would select top. But note, you can create any kind of surface with any of the different links within your corridor model. I'll go ahead and pick top and click the plus sign, and now I have a top surface. If you have any kind of improper triangulation or the triangles just don't look right, you can toggle on Add as Break Line. It does create a little bit of a larger surface, but it'll add the links as break lines, and your triangulation will be a lot tighter. One of the other little tricks that you can do is if you are getting improper triangulation around curves where there's curbing, you can actually add those curbing feature lines. So these would be all the feature lines within your surface. This will just tighten up that triangulation. So I'll go ahead and add the back of curb. I'll add the top of curb, and I'll go ahead and add the flange. This will really increase your triangulation, again, creating nice tight triangles, getting better contours. I'll click OK. It'll ask you to rebuild the corridor, so we will. And just like that, we have a surface. Let's go ahead and take this into the Object Viewer by selecting it, and then go to the Object Viewer from the General Tools panel. As you can see, you now have an actual 3D model of your corridor. What we also have right here is we have a little bit of a problem. And we notice that the triangles are actually going outside the boundary of the corridor model. And so within the corridor surface dialog box, let's go ahead and select our corridor again. I'll go to Corridor Surfaces. There's a Boundaries tab. And what this allows you to do is it allows you to bound the surface. I'm going to right-click on this, and there's a nice little option to select either Corridor Extents as outer boundary or Add Interactively. You can also select a polygon from within your drawing that you could have actually drawn yourself. Note that if you happen to have the same exact feature lines on both sides and the same codes on both sides, this will be here automatically. If you have multiple baselines and different feature lines, as far as the names go, it will not be able to find the extent by itself, and you will have to do this interactively by simply snapping to the different feature lines interactively in the corridor. I'll just click Exterior Boundary, it'll shrink wrap it, click OK, and rebuild the corridor, and now just like that, you'll notice that we have our boundary created for us. Again, the beauty of all this functionality, and the great thing about Civil 3D, you change anything that's related to the corridor model, to an alignment, to the profile, and automatically your surface will get generated as well. Let's create one more surface that will be used for cut and fill volume calculations. I'll click on Corridor Surfaces again, and in this case, we want to add a new surface entry, and we'll call this one Subgrade. And for the surface style, we want none. We do not want this to display at all. This will simply be used for volume calculations. So we'll click on the links, and for this one, you want to select datum. This will be the bottom of the actual proposed surface below the pavement and the curbing, so we can get an accurate volume calculation. We'll click Add, and now I have a datum as a surface. Again, if you'd like to add break line to tighten up the triangulation, you would do so. Also, make sure you select the overhang correction and choose bottom links in this case. That way, you make sure the triangulation goes to the bottom of all the different links within your subassemblies. Click OK, rebuild the corridor, and if I go to the Prospector tab, Expand Surfaces, you'll now notice that we have the different surfaces. Notice the icon looks different than the combined EG because this is telling you it's coming from an actual corridor model. This concludes this video discussing corridor surfaces. Corridor modeling gets you 85 to 90% where you need to be for your design. And then you can use the section editor to review and edit any sections that you want. To get to the section editor, simply select your corridor model and go to the Section Editor option in the Modify Corridor Sections panel. To maximize my screen, I'm going to actually auto-hide the tool space. And you'll notice immediately what you're presented with. You have a plan, profile, and section view of your corridor model. Notice how the contextual tab Section Editor has appeared, which will give you feedback and allow you to manipulate any of the sections and zoom to those sections if need be. So first, let's talk about the display options. If you look on the bottom right here and bottom left here, I've got the profile and the section view. If I don't need, let's say, the profile section, I can turn it off if I want to. In the view tools, any of the viewing configurations or settings that you see here can all be edited. I'll go to the viewport configuration, and what I'll do is I'll actually set this to 2 horizontal, and all I want is plan and section. And then click OK. And just like that, I now have a nice wide screen to show all my sectioning. I can also define how I want the grid to display. As I peruse my model here, you'll notice that nothing is appearing. One thing to make note of is to actually look at your baselines and offsets to make sure that you're on the correct baseline. So right now I need to be on this second one here, because that one is actually going to show me the existing road as well as the existing baseline that I've developed here. I'll just keep clicking next until I see my actually sections appear, and then just like that, you now have all the offset elevation symbols as well as all the pavement depth and so on that we see. If let's say the grid is a little congested in your view and you want to turn it off, or you want to set any of the settings, the display options, I can go to the View Edit options in the View Tools panel. Notice how you can set a scale, you can rebuild on edit, you can change the front and clip planes, because what's actually happening is with this section editor, it's actually zooming down to this location in your corridor model and using a certain code set style to display it, and it's defining some front and back clipping planes so you don't see the rest of your drawing. You can also define the grid. So let's say I don't want the horizontal grid or the vertical grid. I'll set those to no. You can also define what you want the text to be, as well as any kind of code set style that you want to apply. So there is already a predefined View-Edit code set style, which turns all the shading and all the other settings for the links, points, and shapes to be a certain way to make it easier for section editing. I'll click OK, and just like that, I now have my own nice view of my model. To actually select a station to peruse to, I'll go ahead and click on the Specify Station in Planet Profile view, and I'll pick over here, and let's say I just pick some random station right here. Notice how nothing's appearing. The reason nothing is appearing is because I had selected the wrong baseline. So let's go back to the correct baseline, and then we'll pick the correct station. All right, so let's go ahead and pick this one here. Now, because this station is actually not a true modeling location, you'll notice that the Save Intermediate Station appears. What this will actually do is it'll actually model at this location when I click Save, and now I've got a station at that location, which is actually kind of nice if you want to define a station and then make edits to it afterwards. So one of the other things that you can do is, as I navigate through here, I'm going to be looking at my model. You can also change your model afterwards. Well, let's say from station 12 plus 00 to the end of our extra turning lane here, I want to actually super elevate the road on the left side because I'm going to put some drainage down in this way. So even though I could have defined super elevation parameters and tried to define different settings in the alignment, I actually want to do this here because that way I can just tell it, hey, start supering at this station and even apply a station range. So let's go ahead and do that. So at this station, 12 plus 00, I'm going to select the Parameters Editor palette. And what this does, this opens up the Corridor Parameters palette, which allows me to override any of the default settings which are being defined by my corridor model. So what I want to do is select the left side. Notice how they're grouped. And these are all the sub-assemblies within each of the different locations here. So that's pretty cool. It segregates them so you can easily navigate to the location you want to edit. I need to edit the left lane slope. So I'll go ahead and pick left_lane. And again, that's the name of the subassembly. I'll find the default slope property. And I'm going to change this to +2. And then right in my view, you'll actually see this update automatically. Now, the only problem right now is that this is only updating in this view currently, or this corridor modeling station. So I need to actually apply this to a station range, and then the corridor model will update automatically. So I'll keep this located here, and I'll select the Apply to a Station range. Then I can go into my end station and select the Pick Station button. And then in my plan view, I'll actually navigate to the end location where, let's say I'm going to have a catch basin of some sort, or I just want to end this super elevation. I'll click OK here, And just like that, my entire corridor model is rebuilt and automatically showing in that way between that station to station limits. If I zoom in here, you'll see that I actually have the super elevation going in that direction and the label updates as well. If I keep clicking next here, you'll notice that it maintains that and so on. One of the other things that you can do is actually lock down a station. So right now it's zooming to the extent of your subassemblies. If I zoom into a specific spot, I can click on the Zoom to Extents dropdown and select Zoom to an offset and elevation, and now it's locked into there. So if I click next here, notice how it's staying to show me just that location. Also notice the parameters. This is right now telling you it's overriding the default location. If I want to change this back to the default location, I could toggle this off and it would go right back to the default location. I would probably apply that to the station range and all will be back to normal. Once I'm done, I can click the Close button right here to close the section editor, and this will put me right back into the plan view with my updated corridor model. Don't forget, any changes made here will automatically update the proposed corridor surface. This concludes this video discussing reviewing and editing corridor sections. Some of the utilities available that work with corridors are located in the Toolspace Toolbox tab. In the Miscellaneous Utilities category, we have the Extract Corridor Solids tool. The Extract Corridor Solids command provides functionality that allows you to extract AutoCAD solids or bodies from AutoCAD Civil 3D corridor model shapes and links. These standard AutoCAD entities can then be used for analysis and visualization or with other applications that are unable to directly interact with an AutoCAD Civil 3D corridor model. You can export corridor solids or bodies based on an entire corridor region, one or more station ranges, for a baseline, or for everything within a selected polygon. The most appropriate option is dependent upon the intended use for the extracted model data. To start the command, simply double-click the Extract Corridor Solids command. In the Create Solids from Corridor dialog box, you are then prompted to select a corridor model. Once you do so, you can then select the different baselines within the corridor model to extract solids from. Within the baseline area, you can right-click as well to add specific regions and clear your region definitions as well. We'll go ahead and just add the first region here. And then you are prompted to select a station-to-station range. We'll go ahead and start from the beginning, and we'll go all the way to the end. Notice that once you do so, all the different subassemblies that were used to generate the corridor model can then be selected and changed to define the color as well as the layer name that you want the actual AutoCAD entities to go onto. Notice the additional options to pick region by line crossing, as well as add all baseline regions, as you can see here. Let's go ahead and click Next. And in the output options, there are a few different ways to create AutoCAD 3D solids. Click on the little drop down, and let's discuss the three different options available. The first one, which is AutoCAD Bodies, will use the shapes and links to generate a model that matches the way the corridor is constructed. While AutoCAD Bodies are visually similar to AutoCAD Solids, there are some limitations to extracting bodies. For example, functions like calculating mass properties do not work on AutoCAD Bodies. You can choose to extract one of two types of AutoCAD solids from your corridor models. You can extract AutoCAD 3D solids or AutoCAD 3D swept solids. When extracting AutoCAD solids, shapes are used to generate a model that matches the way the corridor is constructed. Extracting AutoCAD solids work best if you plan to use another solid modeling application to further refine the model. If you choose to extract AutoCAD swept solids, points along the corridor are used to generate the model. Extracting swept solids can result in a smoothed solid model that lacks tessellation at sample points, but the model may not actually represent the original corridor. Choosing to extract either type of AutoCAD solid offers more benefits than extracting AutoCAD bodies. For example, solids let you graphically represent the mass of subassemblies, which is supported by AutoCAD bodies. This gives you the option to extract mass properties, such as volumes. Let's go ahead and choose the AutoCAD 3D solids option. Notice the other options to insert them into the current drawing or to add them to a brand new drawing. If you add them to a new drawing, they are not linked to the corridor model. They are completely separate AutoCAD 3D solids. For now, we'll create these in the current file. Let's click Create Solids, and AutoCAD will create the 3D solids. What's great about this functionality as well is if you send this file to someone else who does not have Civil 3D, they can then use the 3D solids to actually generate visualization, again, as well as using mass properties. Let's go ahead and freeze the corridor model. And now all we have are the 3D solids. I'll go ahead and take a few of these into the object viewer by just simply selecting them. And as you can see, these are true 3D solids. Notice how the wireframe is showing and displaying the true 3D solids. Again, the great thing about these is the fact that they are AutoCAD objects. They honor the same standard AutoCAD solid functionality. For instance, I can select a 3D solid. Notice how it selects the entire daylight area. I'll go to the Properties palette, and I can even change the material to whatever material I want that solid to be. So let's make it grass short. I'll go ahead and select that one, right-click, and take it into the object viewer. And then we can change this to realistic. And as you can see, it's using the actual grass material. This concludes this video discussing corridor utilities.